viewers, we've brought you to the video for a cosmology segment. Twitch.tv/smAsho is our Twitch URL. Thanks to our YouTube subscribers as well, wherever you're watching, even if you're watching on BitChute, cheers, leave us a comment, support the channel via the links below the video. Perhaps consider becoming a patron. And here's today's cosmology segment. Should be interesting, it usually is. We've got a bunch of stories here. Starting out with what is going on with the X-ray emissions from active galactic nuclei. So this particular active galactic nucleus, you can see right from here that it's got a quasi-periodic X-ray emission. Big spike, quiescent state. Big spike, quiescent state. And so on from this small area around the nucleus of this galaxy. So, the point is, folks, that there is a relationship between the X-ray output of the galactic nucleus in terms of its torus versus its polar fields. And so here's another interesting example of some work done by the SRG-E Rosita, the Max Planck Institute for Extraterrestrial Physics. And quasars are a type of active galactic nucleus. We're going to talk about this a little bit more. I'm just letting the article scroll here in case anybody wants to read it by pausing the video. And it's not really fully understood how this is. Is it because of some sort of a high-density object orbiting the supermassive radio source at the core of the galaxy? Is it caused by perhaps a tidal disruption event? Maybe there's a star orbiting it, which would be an area of higher density in the torus. Or maybe it's something else. Who really knows? But anyway, quasi-periodic X-ray outputs. That's a phys.org article. And next time I want to look at a non-random number 946 on the Neil Gorell Swift-Bat X-ray Observatory, probably the most important X-ray source besides the Sun to planet Earth. It's Cygnus X3, the tail of the swan, Deneb, the brightest intrinsic object visible from the Milky Way galaxy, from our location, in the Milky Way galaxy, from our location. That's too many prepositions. This is the most intrinsically luminous object visible from Earth. Cygnus X3. There are the X-ray outputs. And I would note that we've seen this very X-ray loud state right here, a very dense series of bursts. And this is an interesting object as it's one of the only known cosmic ray point sources. It has about a 4.8-hour daily periodicity. It's a high-mass X-ray binary consisting of a supermassive radio source orbiting a Wolf-Rayet star, which is so huge that if it were in our solar system, you'd be inside of it. It's about the size of Mars's orbit, and it also outputs about 10 times the heat, particle radiation, and X-ray flux as the Sun does, about 10 times. So where the Sun's solar wind is 300 kilometers per second, Deneb's stellar wind is about 3,000 kilometers per second, which brings us to the fact of perspective. So, in astronomy and cosmology, perspective is everything. Here's an artist's rendition of a galaxy. If you were, say, out here, and you were viewing this galaxy from this angle, it would appear like a Seyfert 1 or a Seyfert 2 active galactic nucleus. If, however, you were viewing this galaxy from an orientation like this would appear as a radio galaxy, such as Cygnus A, the strongest radio source in the sky, otherwise known as 3C405. Last but not least, if you're viewing this galaxy from someplace like here, or even here, from this perspective, this galaxy would look like an ellipsoid galaxy, which would be extremely bright in X-ray, known as a blazar or a quasar. Perspective is everything when it comes to looking at distant objects like galactic nuclei. Here's another article about supermassive radio sources believed to be black holes. They like to eat, but they have a variety of table manners, as these things don't just behave like vacuums. Contrary to popular belief, black holes also behave like fountains. And once again, I would note the fact, folks, that there is a relationship between the torus, and the poloidal jets. So, once again, this is the toroidal region, that donut-shaped area orbiting around the equatorial plane of the massive radio source at the core of the galaxy. And these poloidal fields, where particles are blasted out at nearly light speed. And if you're wondering how it does it, it all has to do with the intrinsic properties of the condensed matter that these massive radio sources are made of. Continuing on, since we've got a jam-packed cosmology segment today, let's talk about Venus. Now, Venus might look nice and calm from space like this as you're looking at a bunch of clouds. Venus is far from calm. It's got a day side and a night side, as a year on Venus actually takes 243 Earth days, and the rotation of Venus is constantly changing. Now, this is blamed on the extremely high mass and viscosity of the Venusian atmosphere. Venus is an odd place, as Venus's orbital mechanics don't fit into the rest of the accretion model formation of the solar system concept. So Venus is one of the many contradictions in the realm of astronomy. How is it that Venus has such a long day and is so close to the Earth's location in the solar system? I find Venus to be much more interesting than Mars. Also, a space flight to Venus would take a lot less time than a space flight to Mars due to its closer proximity. As the planets are not evenly spaced, they're like a magnitudinal graph, as each planet is farther away proportionally speaking than each previous planet. So while Venus does fit into that calculation of distance from the Sun, it's got all kinds of other properties such as its magnetic field and so on that don't really make as much sense. It's also got a very interesting atmosphere full of carbon dioxide, a runaway greenhouse effect making the sun-facing side of Venus very hot and the non-sun-facing side of Venus very cold. There's also sulfuric acid rain and so on. Perhaps we'll do a story later about the Soviet spacecraft that landed on Venus. Let's talk about magnetic fields in meteorites. Now, if you find a meteorite, don't expose it to a strong magnet. You may destroy data. Here's a slice, a 20-centimeter slice of a meteorite found in Australia. And the crystalline structure of the metal parts, especially of these sorts of meteors. And you can see this one is a conglomerate. It's got areas of metal mixed in with the matrix. And that helps to give us insight. And it turns out this particular meteorite was formed in a stable magnetic field. So perhaps have a read on that one as well. That's in the phys.org Astronomy and Space section. Today's astronomy photo of the day from NASA, which is, you can find it yourself.